In this video, we are going to state the 4 quantum numbers. Quantum numbers. Each of the electrons in an atom is described and characterized by a set of 4 quantum numbers, namely principal quantum number N, angular momentum quantum number L, magnetic quantum number M, electron spin quantum number S. Here is a little tips to remember. Nanny loves my secrets. N, L, M, S. N is principal quantum number. It determines the energy level of the electron. Start with 1 and the value must be integral such as 1, 2, etc. L is angular momentum quantum number. It determines the shape of the orbital of the electron. Start with 0 but cannot be greater or equal to n. M is magnetic quantum number. It determines the orientation of the orbital of the electron. The number depends on the value of L. So, M is negative L, 0 until plus L. S is electron spin quantum number. It determines the direction of spin of an electron. The value is either plus half or negative half. For principal quantum number, as the value of n increase, the orbital size will increase and the energy will increase too. For angular momentum quantum number, there are several other names such as azimuthal, subsidiary, or orbital quantum number. The value of L represents the shape of the orbital, such as if the value of L is 0, the symbol is S, which means S orbital. Another example, if the value of L is 2, the symbol is D, which means D orbital. As we recall that the value of L cannot be greater than n, for example, if n equal to 1, the value of L can only be 0, which means S orbital. We can write them as 1s, where 1 is the value of n and s is the value of L, which is 0. For magnetic quantum number, the value of M depends on the value of L, which is M equal to negative L until positive L. For example, if L equal to 0, which is the s orbital, the value of M can only be 0, which means there is one degenerate orbital in S subshell, which is S. If L equal to 1, which is the p orbital, the value of M can be negative 1, 0, and plus 1, which means there are 3 degenerate orbitals in p subshell, which are px, py, and pz. If L equal to 2, which means the d orbital, the value of M can be negative 2, negative 1, 0, plus 1, and plus 2, which means there are 5 degenerate orbitals in the subshell, which are dxy, dxz, dyz, dx squared minus y squared, and dz squared. Here is a little tips. Degenerate orbitals has the same energy. Lastly, but not least, electron spin quantum number. The spinning of electron is either clockwise or anti-clockwise, with the value of plus half or negative half, as you can see in the following video. Example 1. Determine the possible values of m for the following orbitals. A. 3d. As the value of d is equal to 2, so m should be either -2, -1, 0, +1 or +2. B. For s. As the value of s is equal to 0, so m should be 0. Example 2. Determine the possible quantum numbers for the following orbitals. For these questions, we must write the answer in the form of N, L, M, S. A. 5d. The value of n is 5 and the value of L is 2. Hence, the value of m are -2, -1, 0, +1 or +2, while the value of s are +half or -half. Thus, we will have 10 possible combination of quantum numbers. B. For s. The value of n is 4 and the value of L is 0. Hence, the value of m is also 0, while the value of s are +half or -half. Thus, we will have 2 possible combination of quantum numbers. C. 3p. The value of n is 3 and the value of L is 1. Hence, the value of m are -1, 0 or +1, while the value of s are +half or -half. Thus, we will have 6 possible combination of quantum numbers. Example 3. Given the following sets of quantum numbers for an electron, which of the following is not acceptable? Why? Set A is not acceptable. As we can see here, the value of L is the same as the value of n. So, A is wrong because the value of L should not be the same as n. B is acceptable. C is not acceptable because, as we can see here, the value of m is -1, but the value of L is 0. So, C is wrong because the value of m should be 0 only, since the value of L is 0. D is also unacceptable because, as we can see here, the value of S is +1. So, D is wrong because the value of S should be +half or -half only. E is acceptable. F is not acceptable because, as we can see here, the value of m is +2, while the value of L is 1. So, F is wrong because the value of m should be between -1 to +1, since the value of L is 1. That's all for quantum numbers of an electron. Thank you.